So this is where I talk about CNNs. So let's load up. Oh, shoot, this is definitely the older version. I don't know, that's okay. But okay, so CNNs, convolution neural networks, right? So usually we associate this with like computer vision and images. However, note that convolutional neural networks aren't just for images and stuff like this, which even though like if you look online for CNNs, you'll probably find a whole bunch of things. Well, you probably find news articles first, but then go to like convolutional neural networks instead of CNN. And you'll find basically a lot of things on images and stuff like this. But it turns out they're actually really useful for anything that has a lot of like, you think of like relationships that are near each other in spatial, like in a matrix. So one thing's actually really useful is speech patterns. So CNNs are actually really useful in determining things like in speech and audio patterns. So it turns out you can do things like Fourier transforms and basically bring this up and note that different parts of this like frequencies are related to each other. So you can basically say, oh, well, these frequencies are being used closer together, and you can use convolutions for that. So anything that has kind of like patterns that are kind of like bundled together spatially, and I say spatially, meaning like in the matrix itself. Okay. So this is the kind of the overall look from here. So this is not my own image, to be sure. But the idea here is that you, instead of taking like a single like vector, and instead of a vector of like the whole, you know, like image right here, essentially what you do, you take snippets and you create these filters right here. So the idea here is that we basically take parts of our image and we're kind of saving those parts into here. And we do this in different ways with different, what we call kernels and stuff like this. So we basically have different adjustments and stuff, and we have different ways to save the image. So like one part might be looking more for like straight lines, other parts might be looking for diagonal lines. Some might be looking for, is there a bright spot and then a dark spot? So like there's a whole bunch of different things, and that's what these different stacks are going through. And the idea here is that it kind of puts it together where it looks at a matrix at a time versus a whole vector at a time. And then what we do once we have all of these parts, we do some other parts like max pooling. We might do more convolutions on the convolutions. And basically the idea here is that we take something that has a lot of like, what's it called, spatial information, right? So like you can see like, hey, this part of the two is a lot further away from this part of the two. And the idea there, or a better example that I like to use that is a little more understandable, is something like if you had like a picture of like a cat. So if you imagine like a picture of a cat, has some ears, right? Some eyes, a nose, a mouth, like that, right? Okay, so you kind of like know that general idea of a cat and stuff like this. The idea here is that the first part, like there's a whole bunch of spatial information, just basically pixels are on and off, or bright or light, right? Or bright or dark. And the idea for these convolutions is that we start building up these advanced features. So if you remember back to like neural networks, when we had like our different, you know, layers like this, and they start connecting together, is that those layers that are deeper are going to have more like more complex, you know, relationships versus like just straight lines and stuff like this. Something similar happens here where essentially we're looking at just like, you know, oh, what are the edges, you know, are there little swirls and stuff like this? And then we kind of go deeper and deeper until we have, you'll notice that this part right here, the dimension we call like the depth, is a lot larger than what we started off with. So essentially we get like deeper and deeper, like more features. But what happens is that we're not going to have the relationship of like where they are. So at the end here, we might have more like saying, oh, are there ears in it? Are there eyes in it? Are there, you know, is there fur in it or something like that? But where exactly that occurs isn't really shown in the data set. It's, or not the data set, but in the model itself. So the idea here is that we can figure out, say, hey, if it has eyes that are like this, we have ears that are like this, it has whiskers, hey, it's a cat. And the idea there is that we're breaking this spatial information into more context information. And the idea here now is that at this very end, right before this part, is essentially we have a bunch of different features of saying, you know, does it have eyes? Does it have a nose? Does it have, you know, fur? Does it have whiskers? And then we feed these features into our classic fully connected neural network. So what the neural network we've been already talking about, usually we'll reference this as a fully connected neural network, or sometimes abbreviated like FCNN. So that's a pretty typical like abbreviation you'll see in like CNNs and stuff like this. And basically the idea here is we're feeding all those features, and then we say, okay, it has these things. And with this kind of like maybe slightly deeper network, you can say, oh, it is a cow, or is it a cat, or is it a dog, or is it a person, or, you know, this huge variety of things. Okay. Does that make sense to everyone? Kind of breaking this overall view of like how we're taking this image, building up these convolutions essentially, And then at the very end, we essentially have a whole bunch of features, and we feed those features into a neural network, or a fully connected neural network. Cool. All right. So this is where I talk about some parts of the neural network. And all right, so man, I've been going through things a lot slower than I usually have, I guess. I'm running out of time, but usually. So okay, I'm gonna really quickly. Geez, sorry, everyone. I can already tell this is the old version because I don't know what happened. I got to figure out if I messed up the old version. There used to be a little information under each part, but I'll tell you what. I'll kind of quickly go over these parts, and then are you guys cool? Maybe like next study group tomorrow, we'll maybe talk about them more in detail, and then we'll kind of transition that into. Yeah, we'll talk about convolutional neural networks, and then we'll make sure to talk about transfer learning as well. Sound pretty good? Okay, cool. Thank you all. It's tough to fit a whole bunch in 1 hour and a lot of times. Really complicated stuff. So kind of starting from here, this is another way to kind of visualize. Like I actually really like this visualization of like taking this information and then putting it into kind of like a deeper and deeper information of like context over like spatial. So you can see there's a lot of spatial. You can imagine kind of like going in this direction of like this X and Y direction, and then in the Z direction is kind of like context. So the idea here is that we have like multiple convolutions being done, essentially looking at all these spatial information and kind of combining it into this void of space. And we'll have like different like layers in this part. So our Z context information gets deeper and deeper, and you can kind of see it kind of spread out. But our spatial information, you can kind of see right here, it's a lot smaller. Like if you imagine like this was like a little picture, your picture is like scaled down really small, but it's gonna have a lot of information on each of these little layers about like what's in that image and stuff like that. And that's the idea of the convolution again. So one thing you kind of look at is borrowed from the curriculum, but it's actually borrowed directly from Stanford's talk about convolutional neural networks, is that the idea here is that we have like this little filter right here. And what we do, we kind of drag this over the rest of the image. And note that we kind of do some overall math to it. We'll kind of go into details about that in the future. But like we do some like overall math to it and we get some output. So every time you see like this gray box being dragged across, you'll see a purple little box kind of being drawn out here. Basically, it summarizes that 3 by 3 into a single number. And so the idea there is that you'll notice, if you look at it carefully, like this is kind of like got this little diagonal going here. This convolution in this case kind of keeps that overall diagonal, but it's going to get some extra information about this. So these different filters are going to find different things depending how you set them up. So the way we kind of design these filters are things like through stride and padding. Basically, stride is going to say, how should we drag it across the screen or across the image? Our padding basically says, hey, you know, do we add some extra, you know, space between, you know, the edges here? So the idea is like, do we drag it all the way across so we get basically every part of the image, or do we kind of like average over here? So you can see there's no padding in this one. So you can kind of goes like at the end and then skips over. So one thing we can do is actually add some extra white space or padding, and we can drag that whole gray box instead of ending it. Can I draw it really quickly? Oops. Instead of having a gray box that would drag it just like up to here and then move on, we would have a gray box that would go all the way to here. And so this can actually pull in some extra information. So there's some things that we can do to kind of add this extra padding through here. Okay. I'm going to kind of save this going through all the way through it. Actually, yeah, I'm going to save these pooling layers to discuss it for next time. But note there's things like max pooling and average pooling. Basically, the idea here is that we're averaging overall or taking an overall information and scaling it down. So we're actually losing spatial information, but the idea is we're hopefully keeping more context. So max pooling, you basically take the max value within this little window, or average pooling where you average all the numbers in there. So we're technically losing information, but hopefully it's just more contextual. And then our fully connected layer, which is this very last thing, where is our normal neural network that we basically pass all those features through and try to classify from there. I'm not going to go through this because we don't have much time, but there's a little interactive example, which is a great blog post. I'll send it to you guys right now, since you guys can check it out before we have study group next time. But this one right here, basically, it shows you like these are all the little values, so the numbers are each of these pixels. So you can kind of see this going through. But what's cool is that you can see here, see if I can, there we go. You can see this little window right here. And this is kind of like the idea of this window being dragged across. And you can see on the right side, that other spot right there actually kind of summarizing. And you can see there's definitely some information lost right here on this right side, but we're starting to find certain values. In fact, we can actually find things like the outline or, different emboss. So you can add these different filters that can help us, find different features overall. So we're losing spatial information, but we're getting more context. And we can see something similar happen here when we take an image and look at just certain aspects of it. Okay, so we'll talk about a little bit more next time. Okay. All right. Yeah, so I'll go ahead and stop the recording here.